In this video, we're going to use our double angle identities to solve a problem. The problem gives us that the sine of theta is 8 over 17 and the cosine of theta is less than 0. And we're asked to find the sine of 2 theta, cosine 2 theta, and tangent 2 theta. Now before I start, let me draw a sketch to show our given information. We know that the sine ratio is positive in the top two quadrants. So I'm going to show that here. And the sine is negative in the bottom two, just in case you've forgotten. The cosine is positive in the two right-hand quadrants. And the cosine is negative in the two left quadrants. And the tangent is positive in the quadrant 1 and quadrant 3, and the tangent is negative in quadrant 2 and quadrant 4. And there's a little saying that goes with that. All students take calculus, and this shows positive trig ratios. So all of the trig ratios are positive in quadrant 1. Notice they're all positive. Only the sine ratio is positive in quadrant 2. The other two are negative. Only the tangent is positive in quadrant 3. Sine and cosine are negative. And in quadrant 4, only the cosine is positive. The other two are negative. So, because our sine ratio is positive, that's this one and this one, and our cosine ratio is negative, less than 0. That means here and here. So the only one that takes care of both of these given facts would be quadrant 2. So my reference triangle needs to be drawn in quadrant 2. And I know that the sine is opposite over hypotenuse, so this is 8 over 17. Now we can use our Pythagorean theorem to find the x value here. We have 8 squared plus x squared equals 17 squared. 8 squared is 64 plus x squared is equal to 289. Subtract 64 from both sides, so x squared is equal to 225, and x is 15. And since my x is to the left of the y-axis, then I'll use a negative 15 for the x value. Alright, so let's do the a part first. The sine of 2 theta, we know from our identities, is 2 times the sine of theta, cosine of theta. So we have 2 times, my sine of theta is 8 over 17, and my cosine of theta is a negative 15 over 17. So when we do the math on this one, we get a negative 240 over 289. That was our A part of our problem. Now the B part of our problem, we're asked to find the cosine of 2 theta. Now we have 3 identities that we could use, and it doesn't matter since we know all 3 sides of our triangle. But since my given deals with sine, I'm going to go ahead and use the identity that says cosine 2 theta equals 1 minus 2 sine squared theta. So I have 1 minus 2 times, and then the sine was 8 over 17. That's squared. So when we do the math now, we get 161 over 289. And then our C part, I'll put that right here. We're asked to find the tangent of 2 theta. And our identity says that that is the same as 2 tangent theta over 1 minus tangent squared theta. So our tangent is opposite over adjacent, so 8 over negative 15 will be the ratio that I'm using. So 2 times 8 over 15, and that was negative. And 1 minus a negative 8 over 15 squared. So the top is negative 16 over 15. And the bottom is 1 minus 64 over 225. So that is negative 16 over 15 divided by 161 over 225. And that quotient then is a negative 240 over 161.